can see that in the energy mix just 2
Okay,
years
so
ago.
good
Oil,
afternoon and
natural
welcome
gas
back
is
from
still
our
predominant
very long
in
lunch.
running the nations.
Um,
Energy from
we've
these
lost some time, but
sources
we'll try to
very
gain
relevant.
whatever
That's
time
to say
we've
that
lost.
the hydrocarbon we have
We'll be going
in
straight
our
to
we're not going to leave
the
them there.
next
It's not
technical
going to sound on the
session,
subsurface. It's hard
and
to
I would
find
like to
them
quickly
and find
invite
them quickly.
the moderators for that technical session. Please let's welcome to the high table Professor Stephen Obrike, who will be the chair of this technical session, and to join him is Dr. Gayu Mosuru. He would act as a co-chair. We also have a timekeeper. Please, I would like to invite to the high table Dr. Adamu Abubakar. Okay, so we'll start, and we hope we should be able to do this in the next 1 hour or two. Mr. Chairman, over to you. There's a mic, a microphone.
Thank you, Mr. Moderator. And I want to welcome us to the afternoon session of the technical papers. I think first things first, we would have to know those that are available for presentation. There are 15 of them, yes. 16, okay. So, Mr. Udeuzu. Okay, you're the one present. So, I think we would have you first, then we'll have Mr. Moses Onyekwere next. So, can we have you? Okay, can we go through the roll call so that we can tick off those that are available and those that are not? Mr. Moses Onyekwere. Is Mr. Moses Onyekwere around? Sorry, maybe a doctor, a professor, I don't know. Just no title there. Okay. Mr. Ode. Ado Farouk. Okay, Ado Farouk is around. Yes. Amanambu S. Amanambu S. Okechukwu. Ikechukwu. Okay, it's not there. Yes. Amanambu S. Ikechukwu. Nobody like that. Salim Bello. Okay, Salim Bello is available. Habu Sarah. I think I'm thinking so. That says she saw Sarah. You're not ready today. Okay, so skip. Mohammed T. Okay, it's available. I can see him there. Eze M.O. Eze M.O. Okay. Say what? Ode is around. Okay. Yes, Anuko is around. Seen her. Musa A. Yes, Musa A. Is he around? Okay, so Musa. Okay, he's all right. Ohakwere Eze. Ohakwere Eze. No, it's not. I didn't see him. Okay. I think we've, yes, that's a Manambu we've called before here. It wasn't around there. Amanambu Ikechuku. Okay, Dr. Raymond, do. Okay. Onyekwereze. Michael Onyekwereze. Ohakwereze. Ofoha. I can't see him. Anuko is around. Eze Stanley. Danjuma Toro. Mubarak Fana. Mohammed Sani. Joseph Alao. Iko Dalo. J.E. Present. Nwandu. F. Aji Safe. YC. Okay. It's not there. So, there are so many of them. So, we have to. Okay, 50. Yes. Is he ready now? So please help me start with it. What's your number? 12. It's not today. Yes, he was just requesting for presentation today. He's Catholic. Yeah, you want to? Yeah, good. Madam is around. Yeah, so I think we're going to start off now. We've taken the roll call of those that are present, and Haja Mohammed has Sekinetu. Yes, I think there's a briefing. You said you just want to give 2 minutes, please, for the sake of the young scientists amongst us. So I don't know who is helping with the mic, please.
Hello, good afternoon. Say good evening. Talking about the presentation, one of us. Thank you. Good evening, all. I just want to add some. Hello. Just to add something to the presentation is an advice and an encouragement. You know, this aspect of forensic, it's a very new area. It's not particularly to Nigeria. We need to encourage, and I also call on Professor Matu to encourage the young ones in this field to come on board. I remember some times back I was in Beijing, went on training, and we came across some group. They were there because China every year they sponsor different fields. The police, army, or even market, business women, different institutions and so on. And it's an area that they really need people so on. I remember I came along with the pamphlet, but I have a friend, I'll still call her if she can forward that to me or if I'm able to get hold of that pamphlet. It's very, very important. And I believe it will go a long way. My experience goes as follows. When I was in the Geological Survey Kaduna office, I was in charge of the rock store and also normally liaise with the library. Kaduna office this is very, very rich, particularly the archive, the library. You may look at them as old stuff, but they are very good material. I remember one man came from, was it from London? He's a security man. So he came in and was looking for, no problem. He was looking for some materials. And guess what was it? It was the Geological Survey map. The old map that was produced during Dr. Ojo's time. He said that's the map he's actually asking. He came with one. It was new. And I asked him, what do you need that for? He said that there was an incident that happened out there and they are trying to trace that incident back to Nigeria. Either it's in the southwest and so on. So, but when he came in, we were able to get a copy of the map for him, and we link him up with the then director. But I don't know how they ended up, but it's all about forensic. What am I trying to say? I'm just trying to say that it is very important. But if you are coming up with such project, you have to liaise with the security agent to get some information on what forensic is. And I believe probably Professor Ababa, Professor Rahman may have more ideas to add to it. That's just what I wanted to say at the initial time when, that board presented. Thank you.
So thank you very much. And we'll call on Mr. Idozo. Okay, sorry. Prof. Yes. I apologize. Nomenclature matters a lot. So you have 10 minutes, huh? Sorry, sir. I think we're moving it to 8 minutes because quite a number of people are on the array here. So just help manage it. Sorry. I apologize. Are you the presenter?
Your time is going already. So whoever is going to present.
Sorry. Which one was? What's your name, sir? Sorry, sir. Okay. Morning section. Omar. Okay. Okay. No. Let's have it.
Okay. Good afternoon. I will be giving a talk on development of 1D and 3D velocity models for Benue Trough and the Cameroon volcanic line region using machine learning. Next, please. And I'll be doing that, taking you through this presentation context from the introduction down to the next steps. Next. Yeah, we all know that we need a dense network of seismographic stations to enable us to develop either it is especially the 3D velocity model. So what we did, I'll just give a brief history why we decided to do this. In 2013, later Professor Karim Audia of ICTP, Trieste in Italy, actually facilitated a joint research collaboration between Nigeria and Cameroon. So what we needed to do was to establish a dense network of seismographic stations and geodetic monitoring stations along the borders, along the border of Cameroon and Nigeria to monitor geohazard. Since whatever is happening in Cameroon is likely, we're not talking about reflection, seismology, or seismic. If you have an earthquake in Cameroon, it's likely that the impact, depending on the magnitude, it could be felt in Nigeria. That was really what necessitated that collaboration. And since that 2013, Cameroon actually took up their own obligation and they established seismic stations. For some reasons best known to most of us here, we were not able to achieve ours, but we actually densified seismic monitoring stations, but not too close to the border as originally planned. Next, please. So the map of Cameroon, the stations they established as a result of the collaboration. And the first map there is showing the Benue Trough and the volcanic line in Cameroon, and the stations we were also able to establish in Nigeria. The closest so far is the one in Gombe, and we also have a one in Akwa Ibom. Next, please. So most of the reasons why the development of a regional, because some researchers have already worked on velocity model on the area, especially volcanic line, where various reasons as stated here, but because of time, I will not be able to list all of them. So we reviewed some literatures, especially from Cameroon authors, and we itemized all these challenges faced by various researchers in their bid to establish a regional velocity model. Next, please. So this is actually the region we worked on, where you have the rectangle. And these are also the challenges amongst the ones I already showed earlier. Next. So these are the authors, the past publications we reviewed. And therefore, the main reason why we went into this study is to see how to improve or to develop for the first time a regional velocity model in that region, comprising the volcanic line in Cameroon and the part of Benue Trough. So it's also expected, if you have a reliable velocity model, location of earthquakes, and even the performance of seismic hazards, and the other geophysical research are actually possible. So the methodology consists of selecting the data covering from 2015, because getting data from Cameroon is actually a serious issue. So we've been contacting them to get data, even though it was a collaborative effort, but they met their bid. But we'll be trying to also do that in Nigeria due to insecurity and other reasons. We've not been able to take stations close to the border. So it was when recently there's a change of headship in their geophysical unit that we're able to get data running from 2015 to 2023. So these are the data we use, and all these processing methods, we follow them. All these actually, they involve machine learning processing using Python program. Next. I think I've already done this. I will not be reading this because it's much. These are all the libraries we use, one after the other. And all these things were implemented in CNN as a convolutional neural network. So to develop the 1D velocity model, which is the basis for the 3D velocity model. We use all these average station elevations, layer cluster absorptions, time travel inversions, where it is available, standard velocity for upper crust. We have to use all that, even the geology of the area. We need to have all those information. And the 1D velocity model assisted us to now form the platform to develop the 3D velocity model, which is the more complicated model, using station distribution. Station distribution is also another issue, because you need a dense network. So the way we planned the dense network, we have not really achieved that. But then we just have to make use of what we have now and see whether we come out with anything reasonable. And
2 minutes
we can
more.
just
2 minutes more.
okay. Maybe go to the next slide. This is the 1D and the 3D velocity models that were developed. And at different depths, we're able to establish the value for VP and the VS, as I enumerated on the left-hand side. And we also determined the Moho depth for Benue Trough region, as well as the Moho depth for the Cameroon volcanic line. Please, next. And at different depth, we also establish velocity, the P wave and the S wave velocity values. Is next. And the VP-VS ratio, we also develop a kind of a grid showing higher velocity VP-VS ratio, which is the below values, and the VP-VS ratio, the upper region, indicating different features and the result findings we got there. Next. And the key findings we got are listed below. Because of time, I will not be able to go through them one after the other. I will also tested the velocity accuracy using the values of root mean square, which were consistently low. And the next step we are trying to do is to see how we can adopt the same measure, because now we are experiencing swarm of earthquakes within Abuja. If we have a concentration of a dense network within Abuja, so we should be able to also establish a velocity model in FCT and also in the Niger Delta, because we have deployed some stations in Port Harcourt, Bayelsa, and Akwa Ibom. So this triangulation will enable us to now give us a kind of data that will help us to see if we can replicate what we have done in the region of Benue Trough, which is a bigger region, and the Cameroon volcanic region. Thank you very much.
Thank you very much. Questions? Yes, sir. Can you give Prof?
Thank you very much for a most interesting paper. It was a pity, you know, the things that interest ordinary people like us, you couldn't dwell on them, you know, depth to Moho, depth, and those are the crucial things that we would like to know. So I hope your professor, you will let him mention those things, you know, so that it's important for us to know. Because, you know, we've done some work on using nodules in the Benue Trough to try and determine the depth to the Moho and where those things have come from. So it's been interesting for us to know with this new approach what we are getting and so on. I mean, we know that maybe beneath the Benue Trough is about 20 kilometers or so. That means the mantle has moved up in that area. Whereas if you go away from there, you get into the normal thicknesses of the crust and so on. So please give me a few minutes to let us see what because we can then comment appropriately as whether these results are different from what we know or they
So
are
you're-
enhancing what we know already. Thank you very much.
Your key findings.
Please take me back to where you have no, back. Not here. Back where you have the two models. Yeah, exactly. So for more depth, around the Benue Trough, we got values between 18 to 32 kilometers. So where you have the shallow depth, it shows that there's a crustal thinning there, while the maximum we got was 32 kilometers from this study. Within the Cameroon volcanic line, it's a bit deeper than what we got around the Benue Trough. Is from 30 to 45 kilometers. But within the Mount Cameroon, the more depth is 24 kilometers, which shows that there's also a crustal thinning around that region.
Thank you, Dr. Kadri. I just want to ask you, even though you mentioned that we need constellation of monitoring stations to be able to triangulate and maybe compute better result for the swarm of tremors occurring in part of FCT county and so on. So I know that on agency NJSA we have a few meters that have been recording. I know you also have. So have you been able to determine geologically what could have been the reason for these tremors? If you have maybe try to, if you have found any reasons, please, I would like you to share your reason with us. Could those tremors be an intraplate induced tremor, or what do you think could have been the reasons? Thank you.
Okay, please, can you move to the slide where you have a next steps? Next steps, almost the last one. I will just rush it through this presentation. And I know that my brother Abba will ask a question because we will be collaborating. The next steps. Yes. So if you see the map on the left-hand side, you see the previous earthquakes recorded or earth tremors recorded within FCT, Atipapi. Then this other one here is the recent August 4, 2026 swarm of earthquakes. The 6 dots you see here, actually the major earth tremors that we determined. Look at the waveforms below. I just selected 2 because of space. So we located 6. In fact, there were more than 30 in number just one day within Abuja here. There were more than 30 that we recorded by our stations within Abuja. So why am I saying this? Going by the hypocentral depth of this event, they are purely tectonic in nature. And I know that we worked with NGSA during the Presidential Technical Committee. We were part of that committee. And NGSA was able to establish a fort running from Kwei down to Abuja and even beyond. So moving beyond that, we've been also to do more research using integrated approach to also delineate. It's almost correlated with what you did, using Aeromag data and other geophysical technique to establish, as a result of the 2024 within Mpape, we've been able to establish a fort, which, of course, the epicenter lied within that fort. And beyond that, what we are able to try to see now, if all these forts have extensions down to the mid-Atlantic reach, because that is where all these channels are coming from. And they are causing minor earthquakes or earth tremors, as it were. Now, why am I saying this? We are already talking with our agency to establish a very concrete collaboration, even though we have an existing one, with the NGSA, the universities, in order to have a central coordinating.
Thank you very, very much. I know you have quite a lot to say, but there are questions that I would want you to answer.
Thank you. Mine is not question, but an appeal through the president. I think it's our time we pay attention to this issue of tremor. And about 20 years ago, I was trying to liaise with someone in NGSA that time. But unfortunately, the thing didn't work out. It is that time we let the government realize that if events continue like this, one day, I just hope that part of Abuja will not disappear. Because but if we don't become active in monitoring this event, it's been happening regularly now. In the past, it wasn't like that. In Oyo North, the same experience. In the past, it wasn't like that. So in the Jebu diocese, maybe once in 20 years, but now the thing is becoming more frequent. And therefore, there's need for us as an association to pay attention to it, and as an association to ensure that government also pay attention to it. And those who are in charge, whether in NGSA or your office, I think it is our time that we work together and ensure that we provide a policy document for the government. And I also think that more stations should be established so that this thing can be properly monitored. And then we can save a lot of things if we take appropriate steps at the appropriate time. So that's just my appeal. So, Mr. President, the capital judge, I hope you take this one capitally.
Thank you, sir. I think it will form an integral part of the communique of.
Thank you. I'm happy that he did say some minutes ago that they noticed faults in Abuja, at least from Nasarawa State to Abuja. I think I had to say something like that. You see, the people have been talking about earth tremors in Abuja. And I want to say that it's a combination of occurrence of fracture, which of course it can be joint or fault, but it's better we say fault, and high concentration of quarry sites. When you have high concentration of quarry sites, there can be, we experienced something like that in Ibadan recently. There was a explosion of explosives. They stored explosives somewhere in Old Bodija, Ibadan. And people fetched the effect as far as UI, even outside Ibadan, the effect of that explosive. So what I'm saying is that there are fractures, and we take advantage of these fractures for, that's what we use to get water from boreholes, because there are interconnected fractures. And if you have explosive, it can trigger off occurrence of these earth tremors. But we should not be calling it earthquake. God forbid we have earthquake in Nigeria. We have earth tremors. Thank you.
Thank you very much, sir. I think we'll take the last one because we've taken up 10 minutes already. Yes.
Thank you very much. For me, I think this is a very, very important discuss. And for earth tremors to be witnessed in our federal capital territory, I think calls for a lot of concern. And if this is the only thing we can achieve in this conference, coming up with a very, very strong communique, I think it will be worthwhile. Ogasa, I doubt if it is as a result of what you said, because this is certainly much more than what we can ever think of. This thing has been occurring. If you observe the period it occurs, is around August, September. Just check the history. So I think something is happening that we have to take clear and precise attention to it. So, and I think NAEC should be seen to be in the lead of this kind of thing that is happening. And I think that is even what led Mr. President to be talking about seismic group. These are some of the things that proposals are being written to see how government can pick active interest in it. And I think this is one thing that we have to move very, very fast. Thank you.
Thank you very much, sir. I think there are lots of work mapping the share zones. Yes, sir. Sorry, where's the mic, please?
When this started, and I'm glad that the director in the survey is here, these stations were established all over Nigeria. The old science and technology, science and tech ministry. If you ask whether Ajakai, BJG or CAFO, and so they established all these stations and were monitoring them and trying to collect data. I know that even on my own campus in Ife, where they said, you will know. And was Mr. Ego, director at the time. You know, so we had these centers, but they've gone into disuse. And I'm sorry about that because those centers were established to look after this. The truth is that if you get in movements, you've got to be on fractures. And what you want to look, if I find for you the map I made of this Abuja area in 1970 or something, those fractures are there. And it's the movement on those fractures that causing the tremor that we're looking at, you know. But I think now that the director is here, the office is here, I think they need to revive or reactivate those monitoring stations that we set up all over the world. This was in the old days of the survey. Thank you.
Thank you very much, sir. Yeah, sorry, sir. I think we're not going to continue. Okay, it's better. It's all right.
Okay, thank you. Just like Prof mentioned, we used to have monitoring stations across the country, but they become obsolete, and because of time, and the county has not been following up on upgrade. Oh, and this thing now. The good news is that we have been representing a budgetary proposal on expansion of the stations. We have few, and then we have, in those few, we have the best highly sensitive meters that are picking, because even the one that happened in recently in what country is that? Venezuela. The meter has picked it. In fact, the one before it, the meter has picked it. It has been picking teleseismic event. And our sister agency, NASDA, their own too has been picking. But we need more. In other, like in Brazil, they have not less than 500 monitoring stations. So we need, and then it's not only government, we've been making the advocacy. Recently, with the last one that happened, one of the communique we provided was even quarries, major quarries, and companies should be putting meters. So you have a lot of meters all over the country. So but then I will also want NAEC, for instance, to lend a voice beyond what government is doing. We have made provision for the last 2 years, but unfortunately, we have not been, there was no release. So we are hoping that before the year ends, we will have money to expand the station. But then I also want to request NAEC to lend a strong voice so that government will pay more attention to it. Thank you.
Yes, please. Let's have his say too.
Thank you very much.
1 minute.
Mr. Speaker. All the things you have said, I should think that subsidence rates can also be calculated based on this earth tremor. There is no how you have an earth tremor without micro or mini subsidence. So if these things are taken care of, we'll at the same time see what is happening and areas likely to be affected in case of a major event. So I am thinking that studies should be done on extended to see if we can calculate micro or mini subsidence rates. Because right now, in the Niger Delta, in subsidence rate in Niger Delta is about 1 millimeter per year now. That is why you are seeing this surge of the ocean towards the riverine areas. It's very serious. And flooding, yes, flooding is very serious. So if this subsidence rate is estimated, then we can mitigate anything that will arise. Thank you so much.
Thank you.
Can I just comment on that?
Yes, I'm holding you responsible. You are the one that's taking 20 minutes out of our presentation.
It's an interesting topic. I think, yeah, you are right. You also, it's part of our mandate to monitor subsidence and even landslides. Subsidence along the coastal region. Landslides in the southeast. We've done extensive job on that. But earthquake occurrence goes beyond that. Because if you discover right from 1933, when we be observing earthquakes in Nigeria, most of the earthquakes we have recorded are on basement complex, not even where you have a sedimentary basin that you say, and the depth, because if you say subsidence, how far does that go? It's in meters. We're talking about earthquakes of maybe 250 kilometers depth, 50 kilometers depth. The minimum we have had in Nigeria is 10 kilometers. That is far away from where you have a satellite to monitor subsidence. It's a good point that you made. So it should be a comprehensive monitoring. And just like Abba said, NAEG needs to come in to midwife all between our center and the NGSC. Once they see that pressure coming from a neutral body, I think something will be done.
Thank you very much for your presentation. It's actually topical, and you could see that everybody had one or two things to say about it. So thank you very much. We would like to take our next, and please, can we agree as a house that it's going to be 10 minutes presentation, 5 minutes questions? If not, we may not leave here today. Thank you, sir. Can you come and give your presentation, please? So can we load it for him? Yes. So it's 8 minutes, please. Yes. Thank you very, very much.
Good afternoon, all. Chairman, technical session, and audience. We want to look at foraminifera biostratigraphy and devolutionary environment of ex-well non-infield Niger Delta, Nigeria. Next slide, please. This is our presentation outline. Next slide. The Niger Delta located at the intersection of the Benue Trough and Gulf of Guinea, southern Nigeria, has and will affect the structural and stratigraphy of the Niger Delta. So the Niger Basin is geologically complex and a carbon-rich province that developed predominantly during the tertiary period. Next slide. Next slide. Microforces, especially foraminifera, have been widely employed in resolving aforementioned challenges due to their abundance and rapid evolutionary turnover and sensitivity to the paleo-environmental changes. Foraminifera is one of the most geographically widespread and diversified group of microfossils. Their ecological sensitivity and rapid evolutionary rates make them an indispensable tool for biostratigraphic resolution. Next slide. The aim of this study is to enhance understanding of the biostratigraphy and paleo-environmental evolution of the learning field through integrated biostratigraphic and paleoecological analysis of the study section. These are the expected outcomes for the contribution of knowledge. Next slide. This is a cartoon of the stratigraphy of the Niger Delta. Next slide. These cuttings, numbering 60, were collected from a section of X-well ranging in depth from 1880 to 7660 feet at different sampling intervals. The samples were described for their textural and mineralogical properties, including the presence of fossils. 20 grams of air-dried representative sample was weighed using analytical balance and segregated into smaller bits in a clean enamel plate prior to soaking. The samples were soaked for 24 hours and washed over 63 micron sieve for foraminifera analysis. Foraminifera were picked and identified using reflected light trilocular stereoscopic microscope. Identification of the foraminifera was aided by published atlases while employing variations in morphological and apertural features. Next slide. Results. The section comprised alternating sandstone and shale, indicating that samples belong to the Agbada Formation. The proportion of shale showed downhole increase, while sandstones are loose, fine to coarse grain, and shale is mostly gray to dark gray. Next slide. This is a cartoon of the depth of the areas that we worked on. Next slide. The result of foraminifera analysis, as shown in the tables, overall 57 out of 60 analyzed samples are fossiliferous or foraminifera. The samples showed low to moderate diversity of foraminifera assemblages alongside other accessory, namely ostracods, pelecypod, and shell fragment. That's the shell, please. The foraminifera recorded is dominated by benthic forms, accounting for 78% of the total abundance populations. Next slide. These are some of the forms that were identified in this study section. Next slide. This is the stratigraphic distribution of some of the selected foraminifera taxa recovered from X-well alongside abundance and diversity. Key, the acronyms are already displayed, and you can just look at it and know what it is. Next slide. This is a pie chart showing percentage distribution of recovered foraminifera. Note the abundance of benthic tests and calcareous benthics from over the area. Next slide. Now, this table shows taxonomic classification of foraminifera recovered from X-well into families. Next slide, please. Age determination and bioisolation. The age of the sediment in X-well was deduced based on the known stratigraphic ranges of identified marker species such as Bulimina, Buniminella, Subsiphosimorphis, Oblina universa, and all that. The age of the study section, please go back. Go back. Go back. Go back, please. You're still going forward. The age of the study sections is considered to range from late early Miocene to early Pliocene. 4 biozones were delineated in the study section. 1. The Haplophoronidis, Hoqui Haplophoronidis Consilla, Globigerina Venezuela zone, interval 1880 to 2960 feet. Age is Miocene to early Pliocene. The next slide. Saccharomyina Bulimina bucciana and Perobulina circularis zone. That's interval there. The age is late Miocene. The Obolina universal taxon range zone, the unnamed zone, 7080. So, next slide. Now, this is a cartoon of what we studied And these are their downhole occurrences and forms that have been identified. Next slide. The interpretation of the distributional environment of the studied sediments
2 minutes more.
was based on the foraminifera assemblage compositions, the lithological characteristics of the sediments, and the known environmental preferences of environmentally restricted taxa along the recovered taxa. The environmental requirements of the extant species have been commonly used to interpret fossil taxa based on the assumption that the ecological requirements have remained unchanged through time. Based on these considerations, the sediments of the X-well were representing a wide range of environments from shallow marine, inaneritic, to
Sorry, that's a technical.
inaneritic to true athaneritic to upper betial. Conclusions. The integrated lithological and foraminifera analysis. Next slide, please. The integrated lithological and foraminifera analysis of the X-ray Niger Delta basin has shed light into the biochronology and the positional environment of the study's stratigraphic interval. The geological composition of the intercalated sandstone and shale indicated that they well penetrated the Agbada Formation. The foraminifera record is dominated by calcareous benthic taxa. In all 90 species distributed into 52 genera and 42 families were recovered. The presence of marker species was used to constrain the age to early Miocene to early Pliocene. The 4 biozones, A, B, and C, named respectively in the study section. The traditional environment, like we said, range from shallow coastal marine, upper betial. Next slide. Selected references. Thank you.
Thank you very much. Thank you for managing your time. You're just on time. On time. Yes, please. Questions. Okay. Yes, there's.
I can see that the slide template is not followed.
Okay. But thank you for a wonderful presentation. I think, can we give him a round of applause, please? So the next person we're taking is Ode Vio. I was told you're around. Ode Vio. Okay. Ado Farouk, you are the next after her. So that when she finishes, yes, you'll be ready. So you have the floor. Can you help out with the mic? Technical.
Good day, sir. Standing on the exiting protocol, Ode Victoria Omakuru, and I'll be talking on evaluation of long-wave radiative exchange done in Gombe State and its environment. So long-wave radiation is an electromagnetic wave that uses heat as its atmosphere. So we checked how it relates with the Earth and also going back to the atmosphere and then back again. So this study was carried out in Gombe State. Let me have the study area slide 6. It was carried out in Gombe State, that is northeastern Nigeria, latitude 10.3 degree north and altitude 11.2 degree east with an elevation of 450 to 500 meter above sea level. So long wave radiative exchange is an important component of the Earth's surface atmosphere energy balance. It involves the emission and absorption of thermal infrared radiation between the Earth's surface and its atmosphere. That should be in slide 2. And at the course of my study, I encountered some problems, which I'll be listing here in slide 3. Limited availability of direct long-wave radiation measurements in the study area. And I now have to depend on empirical models for estimating my long-wave radiation. Different models produce different radiation estimates. I used 3 models, and those models are the Swinbank model, the Dilly-O'Brien model, and the Namailas model. We'll see this thing as we progress. So this study has significance and contribution in the science. It has scientific contribution, it has model evaluation, data contribution, and also environmental application. My objectives in slide 4 was to estimate incoming and outgoing radiation using those selected models, and also to analyze some spatial and seasonal variation in long-wave radiation across the area, Gombe State. Compare their performance of these 3 models and examine the influence of the atmospheric parameters such as temperature, humidity, and cloud condition. These models I used, I not just go ahead to start evaluating. I had to subject my parameters into the models. And one of it, please, slide 9. My Swinbank model, slide 9. Yes. My Swinbank model was able to estimate clear sky long-wave radiation as a function of temperature to its 4th power. And the Dilly-O'Brien estimates the same thing. You can see the models there and all of their equations, and Nemaila. So this one was just focused, the Swinbank was just focused majorly on temperature. It projects a higher temperature compared to the Dilly-O'Brien. The Dilly-O'Brien one was moderate, while Nemaila has a very limited limited approach. Let me have slide 10. We can see after the subjection and the evaluation, we have a higher value to be within the March to April period. That is the pre-raining season. And my highest value was reported in April. Next slide, please. Dilly-O'Brien produces much more moderate estimate as stated earlier, and the value ranges from 559 to 166 watts per meter square as shown in my report. Higher values still March to July period. That's the pre-raining season into the rainy season. And my May 2022 recorded the highest from the chart, recorded the highest value, 16.34 watts per meter square.
2 minutes more.
Okay, and Nemaila also has a Nemaila was very, very limited. Its value is approximately 0.006 to 0.004. Comparing these 3 models, next slide, please. Comparing these 3 models, we can see all of the interpretation, high estimates, much, and Nemaila was just emissivity based. Next, please. Another this thing among them, should I say, something that is very common among them was that they all have a higher value at March, May, and a lower value occurring at July. Next, please, July to August. Still saying the same thing. Next, please. So with this thing, I always recommend continuous monitoring of temperature, and there should be a direct radiometric measurement in all of those stations instead of having to go down, because we just have few in Nigeria, having to depend on just one source, Zasta or NASA, as the case may be. And we should always check local calibration of existing models to recommend improving their performance under climatic condition. Future studies should incorporate longer observation period and additional meteorological variables. Please. So in conclusion, I have this. I successfully evaluated long wave radiative exchange, exhibited seasonal and temporal variation. March to May has the highest recorded value, while July to August has the lowest value, and all of these things. Next, please. Next. Thank you.
Thank you very much. Can we give her a round of applause, please? You are also spot on with time, so thank you for adhering to time. Question, please. Radiation measurements. Can we give her a round of applause? Thank you very much for your presentation. So, Mr. Farouk. So can you load this paper? B17. B17.
Good evening, all. The title of the work is Aquifer Characterization Using Vertical Electrical Sounding in Precambrian Basement Complex, basically in FCT Abuja. It's a measurement based on resistivity, thickness, and overburden mapping. Next. The basic problems are population expansion, abstraction, and blind drilling. Next. Research have shown basically 4 to 5 layer cases in the basement complex. Next. This is the research gap we're going to try and bridge: lack of systematic aquifer characterization. Next. Basement complex basically is crystalline rocks, negligible or zero porosity. Secondary porosity appears as the promising areas to prospect for water. Overburden exceeding 15 meters generally enhances groundwater potentials, according to Alao et al. 2023 and Farouk et al. 2025. Next. This is the stratigraphic hydrological duality. The location central and northeast of Abuja FCT, basically granite, gneisses, and migmatites, while Abaji and some part of Kwali fell under the sedimentary zones. Next. So the method employed here is basically 97 VS were carried out in the 6th Area Council of Abuja using the Schlumberger array, and resistivity obtained from the field was modeled using the wind resist And as a quality control, any curve that falls above 5% RSM is rejected. This is some of the geoelectric revelation at the end of the analysis. Next. This shows the number of VES in each of the area councils. Next. Darza rock parameter analysis is the engine employed in the characterization. Next. Basically, resistivity and thickness are fed into the Darza rock engine. At the end result, we have, it will reveal a thickness, that's the weathered thickness, longitudinal conductance, calculated transfer resistance, and acetrophy, all are going to be calculated. Next. This is the meaning or what each of the parameter will give you. For storage, thickness matters. Protection, longitudinal conductance. And transmissivity and yield is transverse. While the resistivity determines whether conduction or resistive. Anisotropy determines the level of fracture in a particular environment. Greater than 1 indicates fracture or heterogeneity, or less than 1 is homogeneous or 1. Next. These are the equations used in the calculation. Next. 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 Go back. This the results. In Abaji, there were 7 VAS, and the analytics show spurious aquifer protection is revealed there. Longitudinal conductance at exceptional 12.98 at Abaji 05 and 9.0 at Abaji 04. Thick conductive clay rich weathered. This indicates high protection. Next of the aquifer. This is the Abuja Municipal Area Council. 20 VES carried out there. Next. And selected VES analysis reveal weak protection across the heavily populated urban core. Low protection, like I said, but there are promising aquifers. When you look at AMAC 17, massive localized yield, transmissivity of about 30,000 on meter square. Next. This is Buari. Next. This selected VES analysis. Key findings, heterogeneous, widely productive. In some areas of Buari are prone to contamination, even as it offers a very high fracture in some of the VES. Next. This is Gwagwalada, 13 VES. Next. Selected few here, predominantly homogeneous subsurface with highly sustainable storage potential. Anisotropy 1 to 1.1. Overburden is robust. When you look at the thickness of Gwagwalada 01, about 110 meters. Next. This is Kuje, 21 VES in Kuje. Next. Selected field there.
It's more.
Unmatched groundwater productivity, immense storage. Yes, next. Next. This is Kwali, weak protection. So these are selected, what do you call it, revelations. Exceptional yield is Kuje 03, Buari 11, highly prospective AMAC, this, Gwagwalada, Abaji, and Kwali. Next. The homogeneous surfaces, most of the areas are intense fracturing. Kuje 10, Buari 20, this. Next. Next. Now, this is revelation of the analysis on the contamination this thing. The thick, rich weathered layer in Abaji precisely is a sign of a heavy protection. Next. This is the clay paradox, Kuje and Abaji. Next. Most stations in Buari and Amak exhibit relatively low longitudinal conductance. Then, the threats must be monitored. These are the threats to be monitored. Next. Next. Now, this is yield versus production analysis. Next. Targets for borehole siting. The highest volume producers are the Kuje 03 with thickness of about 116.47 and Buari of 91,000 meter square. Then sustained recharge capacity are these VES positions. Next. The integrated Daza rock analysis proves that groundwater management in the Precambrian basement complex cannot rely on a single metric. Yield, we look to the depth and fracture of Kuje and Buari for productivity and storage, while on protection we rely on the conductive clay sequences of Abaji for natural insulation and aquifer defense. Thank you.
Thank you very much. Thank you very much for your presentation. Kindly take a look at your flow charts. They were not really telling a story. Just by the way. Questions, please. Yes, sir. Robust.
Is that? Yes, in the modeling. Yes. Yeah. Yes. Yes. Yeah.
Quality control.
No. Normally, what we normally do is we repeat the measurement. Sometimes a noise can give you erratic a curve. You understand? So we repeat the value. In areas that we had time, we repeated the values. Normally there is we prepared our system and we took the system to the field. As we are keying in the data, we are seeing the nature of the curve. Yes, thank you. Yes.
Even areas you think the RMS value is high, sometimes may not be as a result of it, but it's as a result of an anomaly that is actually occurring in that place.
You are right, sir. That's why I said we normally repeat the VES measurement. If we repeat and it gives us the same thing, we have to take it.
Please, if you go back to the configuration of your diagram, let's see all this as from figure 1. No, go down. I mean, I just want to see what we are calling Schlumberger configuration.
Methodology. Go to methodology. Slide number. You are using this video to cover the slide.
No.
Go ahead. Come. Wait here. The number 2 mechanism.
Yeah, the mechanism. Is that Schlumberger configuration?
It's a Schlumberger configuration. This is pictorially represented.
No, my friend. This is when now? I mean,
Is it not when now?
Okay, the picture, yes, yes. What I'm trying to say on the bottom there, I try to explain. When you check the main paper, I use the real Schlumberger configuration.
Yeah,
but
this
I
is
use a tool to produce the PowerPoint, and that tool picked this one, and I didn't bother. I was in a
No,
hurry.
you have to put that. No.
Yeah.
That is not.
Thank God when you check the paper, you will see the right diagram. Thank you.
The
Yeah.
MN should be in the middle of AB.
Yes,
that's
thank you.
Schlumberger. Now, the second point I want to raise: why are you not even producing the curve that you are obtaining in the field?
The reason, sir, is like this work is basically to analyze the aquifer characteristics. And when I sent the paper, it was bulky. I asked to reduce it to only 10. So we look at what to remove that will not change and will not reduce the integrity of the paper.
Yeah, but you see, people make a lot of mistakes on this thing. Looking at the curve alone, you can describe where the fracture zone is, the overbody, and all the rest of it.
On the
it's very important.
Yeah, we have it, sir. We have the curves, but when we sent to the secretariat, they asked us to reduce to 10 pages.
I think you should have, produced one or two for us to
Thank you,
see
sir.
what we are doing.
It's okay, sir.
All right, thank you very much.
If you check the slide before this one,
okay,
it talks about stratigraphic.
This one.
Yes.
Okay.
In the basement complex. So you should be checking those titles. Stratigraphy does not occur in the basement. So don't. These are.
It was an hydrological duality of
hydrological.
Abuja. Like Abuja combines sedimentary and.
Then you say of sedimentary when you remove basement complex.
That is why we have the sedimentary this way and sorry, we'll take care of it.
Yes. Then, like I said before, all your, I know it's AI computations. If you check all the places where you have flow charts, they're actually not. There's no connector in any of them. It is just a beautiful design. It doesn't tell a story. So you will see many of them there. I also wanted to ask you, when you're using Dazadoc, you are looking at, in the basement, you're looking at two different things. The saprolite is one. That's the overburden. Then the fracture is another thing altogether. And when you are computing things like transmissivity, you don't generalize for both of them. You have to have them as different stratas before you can now combine both of them to give an idea
I have two tables, sir.
Okay.
The ones of the calculations and the one that I now selected to explain to save time and space. When you see, I have a black background or darker background for the main calculations, then the lighter one is for the explanation. Yes.
Yeah, just a quick one. I want to be very clear.
Okay.
You recommended Buhari. Is it Buhari or Buhari?
Buhari?
Yeah, and I said a resistivity of 91,000.
It's not the whole Buhari, a particular VES in Buhari.
Has a resistivity of 91,000 ohms meter, and you recommended the place?
No, it's not resistivity. It's transmissivity, sir. Go to that Buhari recommendation. See there now. 91,000 ohm meter squared, sir.
Okay.
Ohm meter squared. It's not resistivity, sir.
Okay,
Yes, sir.
okay.
Yes, sir.
So thank you very much. Your paper too is highly engaging, like we said. It's robust also.
Thank you, sir.
So I know you'll go. Thank you.
Thank you, sir.
Yes, the next person is Salim Bello. Salim Bello. Where's Salim Bello? Go ahead, please.
Good
You have the
evening.
floor.
Good evening, members of the higher table. My name is is Salim Bello presenting a paper titled Near Surface Exploration for Coal Seam within Argungu Kebbi State, northwestern Nigeria, co-researched by Adam Abubakar and Dr. Ologi. Presentations outlined are here from the introduction up to the recommendation. Next slide. The background of the studies. Coal is an organic sedimentary rock that is formed as a result of accumulation and burial of organic matter. That is a plant organic matter, and it remains one of the most important fossil fuel resources, contributing significantly in electricity generation, energy supply, and industrial development. And as stated by BGR 2009, we have about 990 billion tons, making it one of the estimated reserve, making it one of the most abundant fossil fuel resources worldwide. Because it occurs beneath the Earth's surface, so the exploration geophysics provide cost-effective and non-destructive technique in order to delineate its lateral extent and depth of occurrence. So it was reported from the Kebbi State Ministry of Solid Minerals that in the course of digging Handog well, the carbonaceous layer was intercepted at the approximate depth of 17 meters. So this is the location of the study area. The map here shows the location map of the study area, which shows the distribution of the stream and everything, and it lies between the latitude of 12 degree 35 minute to 12 degree 55 minute, and then accessible also at approximately 85 kilometers from Kebbi State, from Birnin Kebbi. So the geology of the study area, so the area lies within the Gondu Formation, so which is the upper continental sequence of Sokoto Basin. The rocks found in the study area include sandstone, claystone, lateritic ironstone, and also a localized carbonaceous horizon. So the map indicates the surface geology of the study area, which shows the sandstone distribution and also the alluvium distribution within the study area. So there is a borehole log that was acquired from the Ministry of Solid Mineral, which shows the occurrence of the carbonaceous layer that shows the massive sandstone, lignite, clay sandstone, medium grain sandstone, fine grain sandstone, and this was used to correlate the resistivity response. So this is among the literatures that were used to identify the research gap. So the methodology that were used that is geophysical method that were used is vertical electrical sounding using the Solomveja array. And four electrodes were used, where A and B were used to inject the current to the ground, while M and N are used to see the potential difference. After the acquiring of the data were processed using IPI2WIN and the interpretation using the software. And also after the generation of the curves, then the geoelectric sections were generated so that to delineate the coal bearing formation. Next slide. So this is the during data acquisition of next slide. So another the geochemical analysis were also used in order to see the quality and the content of the coal. So two geochemical analyses were used, which are proximate analysis and the ultimate analysis. In proximate analysis, 4 parameters were measured, that is moisture content, volatile matter, and ash content. And also fixed carbon were calculated. And also in the ultimate analysis, this elemental composition of a coal find out that is carbon, hydrogen, nitrogen, sulfur, and oxygen in order to see the potential usability of a coal. Next slide. Next. So the result among the curves that were generated, this is the VS5, which shows the measured value of the resistivity and also the inverted curve. So the close agreement between the inverted curve and measured curve shows the RMS error of 5.5%. Next slide. So those are the geoelectrical profiles that were used. This is the overview of the profiles and the number of VS in each profile. So the interpretations were topsoil, medium grain sandstone, coal bearing formation, and also a bedrock. Next slide. And this is the geoelectric section of the profile one that shows the coal bearing formation and the depth of the coal, which is between between 2 meters to approximately 10 meters, and it shows where the lateral extent of a coal from 0 meter to 100 meter, where from the VES5 the coal bearing formation literally pinch out, where at the rest of the places the sandstone become dominant across the profile. Next slide. And this is the result of proximate analysis and the ultimate analysis that were used. So for the proximate analysis, the values that were found out is that the classification of coal was classified as a lignite, and also the ultimate analysis also were done. Next slide. So the conclusion. So VES were successfully used to delineate coal in terms of depth and lateral extent, and also those curves were used to generate the geoelectric section to show the coal bearing formation, and also the resistivity interpretation was supported by the available borehole log data acquired from the ministry, and also proximate and ultimate analysis were used to indicate and investigate coal sample which is lignite, and also the integrated approach demonstrate that the usefulness of electrical survey for preliminary delineation of near surface coal occurrence in Argungu. So the recommendation, so it is recommended to have the detailed geophysical survey, like a high profile extent of the and the grid of the vertical electrical sounding, and also it is recommended to have the additional borehole log, and also the quality of a coal. Other geochemical analysis should be carried out, like a calculation of calorific value, and also to assess the environmental impact of the coal, and also the resources potential should also be calculated. Thank you.
Thank you so very much. Yes, you're on time also. I hope you know lignite is co-grading. So did you collect samples to check the carbon content to be able to know it's lignite and it's not subbituminous?
Yes, sir.
Okay. Because you didn't mention it. That's why I was wondering why.
Yes,
okay, questions, please. Yes. I can see that generated quite a lot of interest over this end of the...
Yeah, well done. Thank you. I will just ask for clarification. Can you go to that your curve, the interpreted layer? Just go. Let me just clarification. Where is it? Yeah, here. Perfect. Just looking at the thickness. The first layer is 0.4260. That's the problem with this software. It's a free version and it's not going to give you. What's your spread?
So the maximum spread is 50.
It's
AV over
50.
Yes.
And now your total, what your depth of investigation is 5.7. Just know that it's not correct. This is IP2 win.
Yes.
And it's a free version, so it's not going to give you the right result. Get a good software and reinterpret your data. This is wrong.
Thank you.
Thank you.
Yes.
Yeah, thank you very much. I just wanted to point out something. You mentioned somewhere that the coal bearing layer thins out. I think when you're making presentations like this, there are two things that will also help us to understand what you're saying. Number one, what is your, not the spread now, but the movement, the spacing. Did you go from 1 meter, 2 meters, you know, the normal conventional 3, 5, 7, because you might actually be missing out some points there. Then two, I think it would have been good if you have the place where you say you saw in the log where you encounter it at about 17 meter, it would have been good if you have a control profile to characterize what you are having, because it will be difficult for you to convince people that this is lignite, this is coal. It's possible you have it in your main work, but I think it's something you could have shown us, because characterizing it with a known thing will be able to help us to agree with you that the layer that you are calling your coal layer is actually your coal layer. Thank you.
Yes. Please. Okay.
Good afternoon, sir. with respect to your interpretation, basically electrical sounding is your method, and the fundamental factor is the resistivity value. Now, when you're talking about coal placement, sandstone, shale, coal, I want to ask a question. What's your model for differentiating shale from coal? What was the standard and the parameter, and in terms of your characterization, just to buttress what he was saying? Because if you're spacing, it's a very funny scenario, and it's a very difficult, it can easily be missed. So I just want you to share more light on that.
Okay, thank you. So the geophysical method that were used, so for the interpretation of the coal bearing formation, this interpretation was supported by the borehole log data that was collected from the ministry. So
Okay.
Okay. Thank you very much. Please go back to that slide. Where you have the bow. Okay. You have your coal here. At what depth?
at approximately 11 to 12.
Now go to your geoelectric section. This one. At what depth do you have it here?
About 10, 2 to 10.
2 to 10. Where is the correlation?
Correlation.
Yes.
That one is not from the same place. So it is from the same formation. So I just use it for.
No, there is no one around 10 here. If you look at this diagram, from beginning till end, there is no coal seam around 10 meters. But when you did a log, there was one we saw. That means you missed out that one. It's not on this. Maybe it's in another location, not on this site. This one.
Yes.
Do you understand now?
Yes, sir, it's from another location.
Okay, different
But
from
the
what
same-
you're presenting
but the
here.
same formation.
I accept that.
But it would have been good if you have something around that place. Again, look at this depth with this thickness. It will be very, very difficult for you to pick this layer with your VS at this depth, because this is just about 0.5 meter at that depth, and with the spread you use, it's very difficult to pick it with your VS.
Maybe for the sake of the future, let's look at that profile. You know, sometimes we make small that profile, that geoelectric section, the geoelectric section. Good. I don't know how we are labeling this as verse 1. Which one is the verse 1? Is it between the two dividing sections, verse 1, verse 2, verse 3? You must state where is the verse 1 there?
It's a point.
Is it? But when you are reading this, does it look like a point? These are small things that but it can confuse everything that you really want to do. That is, please, always write it correctly.
Okay, so some of the challenges you will be having, especially when exploring for coal, is because you will be looking at issues of suppression, lateral suppression, issues of equivalence. If you look at your coal thickness, you have less than, just as Prof mentioned, less than 0.5 meter of coal. But if you look at your model, you're almost having greater than 4 meters of, that's over 16 feet of coal. So it doesn't add up. 4 meters of coal. See where your coal started and ended up around maybe 9. So you're talking of close to 15 feet of coal. We don't have that in the country. I can tell you that. Continuous seam of 15 feet. So because this would have been world class for Nigeria. So you look at that. If you also look at where your coal is occurring, it will be very difficult for you to use only VS to characterize the thickness of that coal. It's too thin for you to do this. So you have to have that in mind. Yes, and if you do your proximate and ultimate analysis, it's also good. You take certain things into consideration. If I ask you now, the samples you used, how long were they exposed before you carried out those analyses? Did you take them in situ, or you took them from where the coal was dumped? Because we know that coal undergoes ashing over a period. So a coal that has been left exposed for 1 month can never be the same with that one left for 2 months. So what we encourage people is that if you're taking any coal sample, because it can undergo internal combustion on its own, it can never be the same. But if you're carrying out a study to look at the level of degrading of that coal or ashing percentage of that coal, then it can help us. Thank you.
Yes. After that, I'll take 1 minute,
thank you.
please.
Thank you, Mr. Presenter. You have done well. I just want to make an observation, which of course may bring solution to the question Professor Emen Yusuf asked. Go to the curve. The curve. Operator. In this image or figure, we have two sections of diagram. Is that? And there must be correlation between the two. So by the right, you are showing us that you have 4 layers, 51 going to the infinity. But by the left, you only have 3 layers there. One, two, three. Is what to the infinity, ba? Is it 5?
Yes. I think we will discuss that with him. Yes. It's there. I think I would agree with his 5. I agree with his 5. Yes.
Thank you very much for your presentation. Mine is also an observation, and it's mainly on your topic. Can you go to the topic, please? Near surface exploration for coal seam. This topic is too complex, and to me, this is not the topic is not capturing what you have done. It's better you said maybe integrated electrical resistivity and geochemical investigation of near surface coal of the respective region you carry out the work. Please take note of that.
Thank you. Thank you. Yes, please. Can I?
Mine is just a small contribution to what we are saying. You see, we make a lot of mistakes in electrical resistivity interpretation. The issue of the boundary conditions, nobody considers boundary conditions in this one here. If you really want to understand the type of software you will use, you have to understand the geological environment you are dealing with. It's very, very important. The people who started this sampling, we have sampling of 3 per decade, 9 per decade. The sampling started with 3 per decade, And this was started in Delft Technical University by Kufud. And there are boundary conditions, there are laws guiding all these things before you start taking your sample. So, and that is why you got it wrong. Your interpretation does not tally with what is happening in the field. So you need to do some, more theoretical work, more work to be done. And I would strongly advise that you add one or two other methods. No method is absolute. And that is just it. If you have your data, if you cover the whole area with sanding, and you pick that layer where you are suspecting coal, right? Take the apparent resistivity of all this thing and then contour it. If there is coal there, it will show. I'm just talking from experience, yeah. Yeah, I saw that. That is it. Thank you.
Thank you very much. So please, thank you for your presentation. You can see that it's generating quite a lot of discussion. And a parting one for you is this. You only use the word schematic when there is no scale attached to it. You are saying schematic, some part of it are not drawn to scale. But I saw a scale there and you still call it schematic. So just note those little tiny area. Thank you very, very much. Yes. So our next person is Mohammed T. After Mohammed T, we are going to take Ajagun A. Jonathan. Mohammed T, are you here? So the floor is yours. Mohammed T, where is it?
Oh, please, B19.
Yes, B19. B19.
I stand on the existing protocol. Good afternoon, everyone. I'm presenting on a nuclear analytical technique application in resource mapping, ZARIA. And this is carried out by a team of scientists, including geologists, physicists, chemists from the Center for Energy Research and Training, Ahmadu Bello University, ZARIA. Next, please. Nigeria has two main challenges when it comes to feeding its populace. One is the old method of practicing agriculture, and the second is limited farmland relative to the size of the population. And we know that soil resources, please back. We know that the soil resources are not renewable because it takes about 1,000 years to produce just about 2 centimeters to 3 centimeters. Using nuclear techniques can help improve soil process monitoring, and also ensure agricultural production, food security, and human well-being. Next, please. As I mentioned earlier, this study was carried out in ZARIA, specifically at Geological Sheet 102, SW, that is the Southwest Quadrant. And we collected about 120 samples. If you can see the middle diagram there, sketch, some areas are green and some few at the bottom are red. Those areas are around Giwa local government where there is insecurity and we couldn't take samples from there. And of course, there is breeding and then taking of the sample physically. And each sample is comprised of composite samples where we take not just one sample, but about 7 different samples from different distance to the exact point and combine them to form a single sample. Next, please. And the analytical method in question is neutron activation analysis, which we use the first reactor in Nigeria. It's called Nigerian Research Reactor. It was commissioned back in 2004, and it received a second life in 2018. Next, please. And this neutron activation analysis, something is missing there. But it's a non-destructive technique which uses neutrons to bombard the samples
to create radioactive isotopes of those materials. And those radioactive isotopes are what we study to give us an idea of what is contained in this particular sample. It can take from about 2 minutes to about 14 days to generate the concentration of whatever is within any given material. Next slide, please. Okay, put it, something is missing there. Anyway, back. Can you go back one step? Okay, forward one. Forward twice, one more. There's supposed to be a slide behind this, but the information is that neutron activation analysis is a non-destructive technique, and it comes into its own in that it's free of matrix effects. Whether the sample is in solution, it's in rock, it's in soil, it doesn't matter. The neutrons can penetrate to the depth of the material, and the gamma rays that are produced can penetrate out of that material. And here we just have a certificate of proficiency exercise that shows how accurate the results are. Just one, not yet done, please. Can you go back? It's measured by disease score, and disease score in most instances is quite excellent in that a second criteria is created the Z prime score, meaning that most of our scores are about 99% accurate. Next. These are just some of the results that were obtained. Here we have the soil pH analysis, and it shows that you have quite spatial distribution. In some areas you have acidic soil, in some areas slightly less acidic, and in some areas about neutral. And overall, it shows that there are areas where you can have high retention of nutrients, especially where you have high CEC and low acidity. Next slide. It also reports some soil nutrients, including potassium, which is one of the major nutrients. And there are some areas that are showing, the blue and the red areas are showing high concentration, and the gray areas are showing quite low concentration. And some less important nutrients like cobalt, which is a trace nutrient, and it's just required in some few amounts. Here it's in microgram per gram, and it's available in some areas. And arsenic, which is not a plant nutrient, but it's a toxic element. And if you have plants, for example, spinach that takes up a lot of nutrient from the cell, it in such can lead to bioaccumulation of these toxic materials and subsequently lead to poisoning. And this maps is not just for soil, but it can also be used for so many other resources in mining, in environmental monitoring, and a lot more. Can we go to the next? Yeah, a lot of is missing. Anyway, for agriculture, you can look at the soil nutrients and see what is needed so that you have precision agriculture. Instead of just applying nitrogen 15-15 NPK fertilizer, you can choose what is most specific to the soil. Otherwise, you'll be wasting your resources and contributing to environmental pollution, because if you have so much of this within the environment, it can lead to pollution of lakes and so many other entities. It can lead to improvement in balanced diet or planning diets, so that you have what you need exactly out of that. And as for government agencies that are involved in policy making, they can now decide, instead of having a blanket program to grow rice or to grow eggs, you can look at the resources that are available at each location and try to support precisely those crops. I'll go to the last one. And in conclusion, what we're trying to say is that neutron activation analysis can be applied in geostatistical modeling to generate a high-resolution soil fertility map. Our results identifies areas with nutrient-rich soils and some areas with deficiency. And with precision agriculture, you can be able to target precisely what you want, and thereby having a strengthened food security within the country. And this is beyond the soil facility assessment, but can also be applied for groundwater studies, especially if you are looking at isotopic elements, ratios in the elements, hydrogen, oxygen. Aquifers recharge assessment, see whether they are receiving fresh water or there is a fossil water there. Mineral exploration, environmental monitoring, and resource control. Last. So thank you for listening and for interest in using nuclear analytical techniques.
Yeah, thank you very much. Yeah. Questions? You can take a bow. Okay.
Yes, thank you for the presentation. Looking at your topic, neutron activation analysis and geostatistical modeling. I'm not sure I heard anything about geostatistics that he did. So if you have done anything on geostatistics, what geostatistic algorithm model did you use to generate your maps?
Right from the planning stage, can you go to the sampling point, please? Yes, yeah. Right from the planning stage, the sampling points are generated using geostatistics. We have a grid of 2.7 kilometer by 2.7 kilometer to ensure that you have adequate representation. And of course, when you have bulk sample, you need to be able to work it out. And finally, this information is what is used to plot the data. And that is why we have high precision data at the end of the day.
What did you use in interpolation of those data sets? Kriging, inverse, yes.
Sorry, the geologist in the team did that.
It's all right. It's all
I
right.
don't know if Prof will want to add more.
It's all right. Thank you very, very much. Thank you very, very much. Yes, Mr. Ajagun. B50, B50, B50. You have the floor. You have the floor.
Okay, good afternoon.
B16. What is
B50?
B50.
Good afternoon. Standing on the already established protocol, I'm talking about innovative riverbed analysis using integrated geophysical method.
8 minutes strictly.
Yes. A case study of Mountaintop University. That's the vision outline. Please. Next, please. Okay, riverbed characterization is essential in terms of geotechnical, hydrological, and environmental engineering. Basically, study is just about looking at a lake in MTU University. Can you give me the next slide, please? This study investigates Mountaintop Lake. That is, we have a lake in Mountaintop University. And this method, we using like 5 method, geophysical method, talking about GPR, side scan sonar, magnetometer. We use magnetometer, that's Geometrics G882, side scan sonar, a dual frequency side scan sonar, and echo sounder to be able to have the depth profile of the riverbed. Next slide, please. Basically, this is just to give a comprehensive, non-invasive characterization of the lake bed for hydrological engineering, environmental, using this method. What is the aim? To basically map the lake bed, identify buried structures, because from before the construction, before the lake, we had some also to develop an integrated georeference period to model and to support infrastructural management, erosion control, sustainable campus development, and to demonstrate the effectiveness of this integration of this geophysical method. Can we go to the next slide, please? This is the picture of the lake in the MT University, Mountaintop University, and this is the approximate coordinate of mapping the lake bed. Next slide, please. basically, as I said before, single beam echo sounder was used, though it's a dual frequency echo sounder. I used Mala GPR, also marine resistivity, marine ERT, side scan sonar, and also magnetometer. These are just the method that was used on this study. Basically, as I said before, Mala 160 megahertz was used. Previous information has told us that 60 and 160 megahertz GPR was used on the lake bed, but we were able to get better results using the 160 megahertz. Also, the marine the marine ERT, AGI superstring R8 profile was used just to map the river. This is the result of the this is the result of the this is the result of the okay we use magnetometer, we use G882 and side scan sonar. Can we go back to the next slide? Okay, we have the result of the bathymetric information along the riverbed. So to be able to depict the depth, because the depth will be used to map the profile, which is also important in the other method. Can we go to the next slide, please? Also, Mala GPRS was used, total of 127 lines, and the initial processing was conducted. We used the Mala Vision, Geolytics, and we did a lot of also correction using some of the softwares. Can we go to the next slide, please? Also, the GPR was successfully imaged about the first layer, which is about the waterbed, because we have no reflection. Also, we have eye reflection, which also interpreted. On the second layer is about the mud, and the sand to clay layer, the last layer was the clay. But basically, we are interested in some of the anomaly that the GPR also gave us. Because from the, if we go back to the next slide, before this slide, please. Okay, at some point on the GPR, we were able to delineate about some irregularities, anomaly, which when we mapped the GPR, the magnetometer, and the side scan, we were able to map out that at this junction, at that spot, there are possible relics of the wooden, because there was an existing bridge that was there before. So the method were able to identify that there are some anomaly around that spot.
2 minutes more.
Can we go to the next slide, please? Also for the ERT, we mapped out the different layers. We mapped out the different layers. Also, during the next slide, I'll go to the next slide. If you look at all the 1, 2, 3 on the 3D, we can be able to see the anomaly at that spot. When we now combine this method of the ERT, the result, and the result of the magnetometer, and the result of the GPR, we find out that there's an anomaly there, and which was traced to former relics of the existing bridge, because there was an existing bridge, wooden bridge, that was demolished before the lake was dredged. Also, these are also some of the results of the magnetometer. This one was, we used also Oasis montage coupled with a maglog to bring all the data together. Same point, as I said, at that point, we were able to identify that anomaly around the same point. Of course, all this method, we use GPS, both on the magnetometer, on the side scan, all the sensors. So we are able to map all this one based on their coordinates. This is also the result of the magnetometer, just to be able to identify the depth of barrier of that magnetometer anomaly. And for magnetometer, we use continuous sampling to get it. From there, we use maglog, we use Oasis montage to be able to delineate that particular anomaly. Also, this side scan sonar, some of the images, because of the slide limitation, we're able to just put about 2 or 3 slides of the magnetometer mosaic that depicts that same anomaly around that area. These are all just integrated model, bringing all the methods together in terms of all the lines for 27 line for the 27 line for the GPR, the ART, the side scan sonar, and the magnetometer, just to be able to characterize the lake bed using these methods. Can we go to the next slide, please? So, conclusion: integrated GPR, 2D ART, magnetometer, and side scan sonar produce a high-resolution georeference model of the MTU lake. Delineated surface stratigraphy identify weak geotechnical clay layers and maps of submerged bridge remnants and other buried anthropogenic features. Multi-method integrations quickly reduced into uncertain and improved confidence compared to the work that has been done before. So with this geophysical method, we can be able to say that, because geophysical method, most of the time, one of them will complement each other. With all this complementation, putting all this geophysical method together, we can be able to derive that at this point, this is where the relics is. And also, what are the recommendations? Is to use deep foundation for future infrastructure to avoid weak clay zones, incorporate georeference maps of buried features into campus planning, dredging, utility routing, and infrastructural development. Remove or stabilize submerged metallic debris and bridge relics to improve environmental quality and safety. Adopt this integrated geophysical workflow as a framework for the riverbed. Next slide. Thank you.
Thank you. Thank you. Thank you. Yes. You said weak geotechnicals. I hope you performed geotechnical tests to know that the clay is weak. Because there was no proof of that in your work. So don't use so yes, questions please. It's a very rich presentation.
Thank you.
It's a very rich presentation. Questions?
Though we have to look at the further study, because initially we also plan to do some boring at those points to be able to complement.
Just say clays. Leave the word geotechnical, remove it from it.
Okay, sir.
That's what Prof is saying. Just respond.
Okay, sir.
Thank you very, very much. You can take a bow.
Thank you, sir.
Yes. The next person that we are having is Geraldine Reddy. She's here. Anuku, please. B20. B20. That's our paper. After her, we'll be having Eze M.O. Is Eze M.O. here? Please, you have the floor, Doc.
Thank you very much, Chairman, sir. A very good evening to you and the entire members in this session. It's a pleasure to be here to present our paper titled Integrated VLF-EM and Smartphone-Based Magnetics for Subsurface Characterization and Mineralization Targeting in Ojeowode, southwestern Nigeria. The next slide, please. So this will be my outline for the presentation. Next slide. By means of introduction, it is a known fact that Nigeria plays host to significant amount of minerals, and a very critical part of understanding these minerals involves mineralization targeting, which refers to the process of identifying and delineating areas within the subsurface that have a high potential for hosting economically significant concentrations of minerals and or depth. Geophysics, as we all know, is a major tool that can help us in mineralization targeting. And integrating geophysical techniques is very paramount in these studies. And that is why several authors have made use of integrated geophysical method, especially VLF and EM, to be able to effectively identify mineralization potential in different parts of the country and other parts of the world. Ojowode is a geologically promising location. Why? Because of its proximity to Shekpeteri, which is known to be an active mine site. And the subsurface, however, remains insufficiently characterized for its mineral potential. And we thought it wise to be able to adopt a rapid and cost-effective technique to carry out preliminary mineral exploration for the purpose of various benefits for both the country and even the community. The main aim of the study is to characterize the subsurface for mineralization targets with all of these objectives that we have outlined. And the major key parameter of which we try to utilize here is the use of an app, a magnetic app, to be able to carry out some of these objectives. The next slide. So this is the study location. It shows the study area somewhere at the right-hand part of the map, the northeastern part of the map. That's the study area. We have structure-controlled faults, folds, joints. All have been reported in literature. The next slide, please. And the basic theory for this work, we utilize the VLF method as well as the magnetics. So the VLF is known to be able to fractures, shear fault zones, and all, while the magnetics of importance is the fact that the mineral and concentration, the strength of the anomaly gives us an idea of the mineral concentration as well as the shape of the material of interest. Please, the next slide. These are the works that have been done in and around this particular area, and even different not this area, different parts of the country, and also internationally also. The next slide. Of particular importance and why we utilize what we utilize was the report of Oshinowo and Falufosi in 2018, where they utilized VLF-EM, and they recognized that the derived current density with matching high residual positive magnetic anomalies closely correlated with signatures that were evident in already existing gold and associated metallic mineralization of the pegmatite vein. So that was the basic premise in which we'll be utilizing for this study. The next. So the methodology, we adopted, we carried out the investigation along 12 traverses. We were able to see if we could achieve a grid-like in the left-ended portion. That's the northwestern portion of the study area, which is tagged Block A. Then the other part that we scattered around the town is Block B, with a station spacing of 10 meters, and the VLF and magnetic measurements were carried out. Next slide, please. So this is how we carried out the VLF. We used an EM16 receiver transmitter. For the processing, we had to processing the Fraser filter was first done, and also the Carroll's Hill jets to produce these various output. Figure 9, which is the Fraser filtered plot, as well as the relative pseudo-density, the Carroll's Hill jet pseudo-density of the subsurface. Next slide, please. Then of interest is this particular one. We utilized for magnetics, because we could not carry our magnetometer to the field, we utilized an app called the Firefox app. The Firefox was developed by researchers in a university in Germany, and that app gives us an ability to measure the magnetic field of the Earth. So with the app, we didn't have to utilize our magnetometer. We just utilized the app, and this is the output of what the app gives you. It gives you the X, Y, Z components of the magnetic field, as well as the absolute magnetic field. So for our investigation, it was the absolute magnetic field that we took at each station. And we carried out the various, all the necessary precautions that is necessary while taking your magnetic readings. No belts. We held our phone steady, and we removed every form of detection to the magnetic field that we could encounter. And the processing was also done using standard processing technique. And this shows the raw in-phase and quadrature for all the traverses, and we were able to identify lines where we had the in-phase swinging to from positive to negative, which is the classic VLF conductor axis. Another thing we noticed from the raw data is that the persistent quadrature offset was relatively lower than the in-face, which signified that the the near surface is conductive, suggestive of whether clay-rich regolith that blankets the basement. The next slide. So this appraiser filtered for all the traverses. We could identify 28 conductive zones based on the positive peak anomaly that were observed. Of particular interest are the strongest conductors in T11, T7, T6, 9, 1, 5, 8, and 12. Please, the next slide. This also gives us the Carousel-Jar pseudo section. Of particular interest also, we were able to identify the shallow conductive zones, which are shown in red. This is a relative plot, so it doesn't give us the actual quantifiable conductivity, but just gives us an idea. So we could also single out conductive zones that runs from the surface down in traverses 2, traverses 5, 7, and 9. Please, the next slide. So for the magnetics, which was what we utilized, the magnetics reading was actually quite interesting, and we noticed that it actually correlated significantly with the VLF reading. And also the range of values we were getting was the expected range of values within the equator that we were expected. So we got amplitudes. After processing, we saw anomaly amplitudes that range 1180 to 4,962 nanotesla. Of particular interest is traverse B, which showed the maximum or the strongest amplitude. And we also had strong amplitudes on T1, T4, and T6. Please, the next slide. We also conducted a Euler deconvolution to determine the depths to the magnetic source, to the anomalies that were obtained, and the depth to the principal source was consistently shallow, ranging from 13 to 20 meters. Euler structural index was also carried out, which suggests that these source bodies are dike-like in nature. The next slide. We also did an analytical signal of the amplitude observed to just ensure that the source bodies were actually placed on where they are supposed to be on the horizontal traverse. Next slide. So this is the result from the analytical signal. Next slide. Please, next slide. Okay. I think I might, even if I end here, it is fine. So we were able to carry out for the block A that we are like more like in a grid-like formation. We're able to carry out a map of the area, and from that we'll notice that there is a strong correlation around this part that you have the high red. You have your high residual anomaly. The high residual anomaly correlates quite significantly with your VLF Fraser in phase, which shows conductive rims and a midpoint that is resistive. And this is very characteristic of massive intrusion, possibly with conductive, altered, or mineralized contact zone. Next slide, please.
Time up.
Oh, okay. Okay. All right, thank you. So in conclusion, we were able to effectively map the mineralization targets in Owode using both VLF and magnetics. And of particular interest is that the magnetics that we had was not the regular magnetics, but just our phone, and we were able to effectively characterize it. References, please. Next slide. So rigorous magnetic prospecting may need not depend on costly instrumentation. So this is something that we can take to the bank. Thank you.
Thank you very much. Questions?
Well, thank you for your presentation. I think it is a good work. I also observed that my own smartphone meter did not work when I got.
Maybe you didn't use the right app, sir. I can do a sample with if your phone is there.
No
It's
problem.
possible.
We'll see later. Because I got one when I went to US. It worked with me. I got back to went. So learned the trick from you. But I also want to find out the magnetic field you plotted. Was it a residual magnetic field or the total magnetic
The
field?
residual, we carried out the necessary.
I was
field
able to
testing.
get that high value.
I actually had to look at it very well, and yes, that was what we got. I was surprised.
I
yes.
will advise that you check again.
Yeah, I
That
was
seems to be too high.
Mm.
These are magnetic values.
Yes, sir.
Wouldn't it have been okay if you're taking maybe a profile, you have your magnetometer, measure it along some sample points, then use the same meter, measure, compare the values. What's the difference? I don't know.
Okay, thank you very much for this. I think I tried that at the last. I was here at the last NAI conference in 2023. If you go to my appendix, I just tried to add that data there. If you could go to the appendix, I tried using that. In Lagos, where I come from, it's a sedimentary basin, and it will be difficult to effectively test that there. And it was not easy to carry the equipment down to this location because of COVID. It was just our students. So this was in 2023, where we went for the NAIG workshop. And during the NAIG workshop, we conducted magnetic measurements using the GEM proton precession magnetometer. And the top value you have there is what we got from the GEM. That's the total, what we have the total magnetic field. So the top is what was recorded by the GEM. Then the bottom is what the Firefox app actually recorded. You see a strong signature, a similarity between the trend from the GM proton precession magnetometer and that of the Firefox magnetometer. Quite interestingly, the Firefox magnetometer, the way I ran it here was like a continuous measurement. So I was just moving with my phone on, and it was just recording the measurements. That's why you have significant number of measurements there. So what I just did was to have a trend line along those measurements, and you see it closely relates or matches what we have for the GM proton precession magnetometer. So this actually was the basis why I could trust the fact that the readings from the Firefox app are quite accurate, and that was why I asked my students to replicate it at Ojo Owode in combination with the VLF, which they could easily take to that place without the stress of carrying the magnetometer down there.
There's no doubt that you put in a lot of effort in acquiring this data. I congratulate you. Nevertheless, you have too much noise in your VLF-EM. And you use VLF-EM16, you said?
Yes.
And you didn't mention the crystal you use, whether it's NAA or FUO.
For that particular one, the EM16, I'm not so sure if it uses the crystal it uses, but I know we tune to a radio. Is tuned to a radio station.
Yeah, it's submarine.
Yes.
You are using
Yes,
submarine
so
signals.
Signals,
you know?
yes.
And
so there's a high level of expected noise, because if you're not, you have to be very careful
yes,
to ensure that.
But even if you get the noise, there are ways by which you can smoothing them out.
I think that's what the Fraser filter. Yes.
Whittle's method. And there's a method we develop in depth because we carry out the simulation of VLF-EM, of which we produce the quantitative method of interpreting VLF-EM in depth. And have you ever heard of fall-off gradient before?
No, not.
Fall-off gradient, okay.
I'll
We'll explain
that.
everything to you if you see me. Thank you very much.
Thank you very much, sir.
Yeah, thank you very much. It was very insightful, and I was trying to pay very rapt attention. It's actually a very good presentation, but I think we should still double-check some things and not get it mixed up. When you are using your phone, that app that you're using is actually giving you the absolute magnetic field. When you go to the field with your magnetometer, like the overawesome magnetometer that we have, it's giving you the total magnetic field. Now, the absolute magnetic field is actually best when you're doing your geomagnetic field, which is a little bit regional. You can actually get some satellite magnetic data also.
Yes.
But by the time you're talking about your total magnetic field, you discover that in the field, when you're recording and you're having 34,000 days, 33,000 days, the anomaly that you're looking out for are very, very subtle. So in your total magnetic field, it's a combination of both the earth crust, the magnetic field, some magnetic minerals in the rock and things like that. Everything comes in together, and that is why we calculate the residual, because it is that residual which are the heterogeneous units at the near surface that is most of interest to us when we're talking about demineralization, because as you go down, the earth become more homogeneous and it's going to be giving you a bulk thing. But looking at what you cross-check it with, the agreement between the curve, I think it's something that one can actually look at and see how one can develop on it. It's a very good presentation, but it's something that I've just been looking at and trying to see how, I think you can look at it also, what is the correlation between absolute field and your total field and something like that. But I think this is actually a very good presentation. Thank you.
Thank you very much.
Thank you. Me, I'm ignorant. My concern is, like, what were you targeting really? What was the what minerals were you?
I wasn't looking at any minerals per se. I'm just looking at potentials, and the potential was based on places where I could have high VLF peak anomaly and high positive magnetic anomaly. It was not a mineral, a particular mineral that I'm looking at. Yes.
The problem is that I don't see we get the geology is important. You must tie this in with the geology, because if there's no geology, it's in the air.
Yes,
it's in the air.
Okay. It's fine.
You must get the geology so that because of that, this area is important for me.
Yes, it's actually there.
Listen, look. My organ mapped Shaki potassic cyanide. Ojeowode is next to that area. And I know that there are all kinds of beautiful pegmatites and things like that, which we were ignorant in those days. I was badly brought up. They told me, look at the origin of the cyanide. Don't worry about the mineral resources that they contain. But now when you are talking of this mineralization there, I'm extremely interested to see, okay, will this be the way?
I had to play down, props, I had to play down on that. I actually mentioned it. Yeah, the geology is there. I actually had to play down on it because of time. And I wasn't, it's something that is continuous. So I can't emphatically say that this is what is here and this is what is here. But in terms of geophysical signatures, the signatures looks promising for mineralization targeting.
Yeah. Time.
Remember that you're looking at various left is on, it's going to be from different transmitters. And that's why we always advise, if you get your hand on a system that can measure in multiple channels. So instead of just having one single channel VLF equipment, there are some. Syntrex has a lot that can measure in 3 different channels. Because if your transmitter position is different from the strike of your target, it's noise. So if you calibrate that way in such a way that you measure at multiple orientations with reference of your target, because it must be target, while your sound. So that's what
Thank you very much. Can you take a bow? Thank you.
Thank you very much.
Yes. Hopefully, you'll be back again. So, Musa A. Gado. Musa A. Gado. Are we here? Okay. Please, kindly come up. C08. C08. That's the paper number, C08. Yes, you have the floor. Your time has started counting.
Next slide. Introduction. Mining terrestrial environment is widely recognized to increase metallic element concentration in the soil and to enforce good water quality down the stream from the mine, and it played major role to the socio-economic development of the country. But after years of mining activities, and when the mining has seen the line is left with large number of ponds, sinkhole, and tin-tailing of waste rock from mining operation. All this can contribute to the environmental problems. Next slide. Statement of the research problem. There are potential risks to environment and due to improper handling of mining waste, that's heavy metal emitted from the mining process. Given the mining activity area and its environment, Yauri can be contaminated, and this can lead to deriving the community of fresh water supply, contaminated the soil for agriculture if not properly contained. Next slide. The research focus on the outbreak in waterborne disease and contaminated water source. That's onion source in Kaswa Albasa that lead to the death of more than 100 people from Maraba and Bilni Yauri community area. Next slide. These are the aims and objectives of the study. The aim of the study is to assess the heavy metal content in water across potential migration routes in Yauri active mining sites. The objective is to determine the lithology in the study area, to determine the thickness and depth of the weather aquifer in the study area, and to determine the concentration of heavy metals in water using geochemical analysis. This is the location of the study area. The area lies along the longitude 4 and 5 degrees east and latitude 10 and 11 degrees north. Next slide. Next slide. This is geology. Geologically, the survey area lies entirely within the basement complex. Next slide, please. This is the theory of the resistivity method. The principle here is Ohm's law. Next slide, please. These are the materials and method. Then for result and interpretations, these are the model curve conducted along the feet, the boreholes, then the hand dunks and the surface water. These are the first one is the model curve for base 1, which has 4 geoelectric layers. The first layer, which is the top layer, has a resistivity of 52, interpreted as clay. The second layer has a resistivity of 487.9, and that can be interpreted as laterite. while the third layer has a resistivity of 203, can be interpreted as the basement, while the fourth layer is the fresh basement. The same thing, the same interpretations. So the curve, the model curve give geoelectric layers 1 to 4. Then the next one is this. This is the same interpretations. The model curve for base 3 has 1 to 5 layer also. The first layer is the laterite, that top layer apparent resistivity of 453 ohm meter. The second layer can be interpreted with a resistivity of 192.
2 more minutes.
The next slide, please. So the same interpretation going on. Then geochemical analysis. Next slide, please. Okay, these are the result of geochemical analysis. This is the result for heavy metals and the conclusions. In the conclusion, the contamination shows that contamination exists with the higher concentration of heavy metals such as lead, iron, and arsenide. And then the result of the base show that the weather aquifers is vulnerable to pollution because it serves as the pathways of the migration of these heavy metals, the weather aquifers and the fractures. So they contribute the management of water, and the result contribute for management of water and environmental monitoring. It's holistic.
Thank you very much for your paper presentation. Can we give him a round of applause, please? It's not easy standing there. Questions, please. Questions. Okay, you said there is contamination. Did you compare it?
Yeah, because the heavy metals, the higher concentration of those heavy, that indicate the contamination in the area.
How did you get it? Did you compare it with standards, or you computed an indices for it?
Yeah, with the standards of drinking water quality.
Okay, the boreholes, how were you able to get which one is sand, which one is clay? Because I can see when you were showing us the VES curves, you were calling some based on resistivity.
I use the control of the borehole of the area,
okay,
and then standard resistivity.
Okay, but you didn't show us the log itself, the control log that you used in comparing.
Yes, it's there in my
It's all right. It's all right. Thank you very, very much. Can we give him a round of applause, please? Geraldine, are you ready again? Let's have her again. She's going to speak to us on building on former waterlands. B23. B23.
Thank you very much. Good evening once again, everyone. This topic will be building on former wetland and integrated electrical and seismic geophysical characterization to support infrastructural development at Prayer Estate, Amodofi, southwestern Nigeria. The next slide, please. So this will be the outline of my presentation. Reclaimed wetlands are extensive sandfield swamp, wetlands, and floodplain areas, and it is not a new feature in Lagos State. And it poses a significant engineering construction, and poor site characterization can lead to foundation failure, cracking, tilting, and costly remediation, which persists in Lagos, as we know. And geophysics is important in site characterization. Next slide, please. And that is why we hope to, for this study, we utilize a suite of geophysical method to actually understand a very critical part of this rapidly developing area, Prayer Estate in Amodofi area. It is a residential area, but buildings are coming up. There are no roads. Hopefully, they will be putting up roads and all of that. A critical concern is that this area was once a wetland. Most of these areas had been sand-filled. Next slide. The aim generally is to characterize the subsurface of the study area with the following objectives: to determine the subsurface geological parameters, the VPVS ratio, delineate the underlying geological units, and estimate the depth to competence layer. Next slide, please. These are some of the literature that we have looked at. And a key pointer is the fact that peat organic materials are low strength zones in Lagos wetlands, and linked low resistivity clay and low bearing capacity to building, cracking, and sinking. That's according to Oyedele and Oko et al. The research gap is that at prior estates, nothing of such had been done. Next slide, please. Next slide. So this is the study area. It's just the base map of the study area showing us the various traverses and that we are done. 6 traverses we are done, and generally the geology of Lagos is sedimentary. Next slide, you're in order. The geology is sedimentary, and the study area is underlain by recent river alluvium with unconsolidated sand, silts, and clays with organic mods. And that's what we're expecting. And 3 different suites of geophysical techniques were utilized. We utilize electrical resistivity survey. We also utilize self-potential method as well as the seismic method. For the seismic, we combine both refraction and the multi-channel analysis of surface waves. Next slide. This is the processing tools that were used. For the data processing, for the 2D electrical imaging, we utilize ResIPy. It's a free software developed in the Python environment. For vertical electric sounding, we use WinResist. For the seismic refraction MESW, we use SeisImager. While for the self-potential method, Excel was used in plotting. And these are some of the results from the 2D electrical imaging. From the 2D electrical imaging, we could see variation in the resistivity of the subsurface. For Traverse 1, which is figure 3, the resistivity varied from 13 to 63 ohm meters, while for Traverse 2, it ranged up to 1,255 ohm meters, showing you that just within that particular area, there is significant difference in the resistivity of the subsurface. And the low resistivity layers were interpreted as clay units, while the relative high, greater than about 140, were characterized as sand. And this is the result for Traverse 2 and also for Traverse 4. You will notice the presence of thick, low resistivity even within the traverses, which can be suspect, especially for engineering consideration. Next slide. This is for the vertical electric sounding. So at certain points, we also took vertical electric sounding. And what the vertical electric sounding did was to enable us to go deeper into the subsurface. And for verse 1, which was also along Traverse 1, at up to 50 meters, we did not get up to the high resistivity zone. But verse 2, we could see that and show you the variation in the lithology, even within a particular traverse. For the self-potential, this is the result for the self-potential for Traverse 1 and also for Traverse 2. And for Traverse 1, we noticed a negative anomaly, significant negative anomaly of about 20 millivolts. Then for Traverse 3, we had a positive anomaly. So the strong positive anomaly indicates significant movement of fluid. We'll get to see that later when I try to marry the 2 layers together. And the negative response may also reflect electrochemical effects associated with saturated clay or organic materials. The next slide, please. These are some from other traverses. Traverse 2, no significant anomaly. While for Traverse 4, no significant anomaly compared to the previous Traverse 1 and 3. Because this is just about 6, the peak, yes, millivolts. The next slide, please. So for the seismic refraction, for this particular presentation, we did not do the real quantitative interpretation or the tomography interpretation. This was just a simple first principle interpretation. And from the first principle interpretation, we obtained the velocity of V1 as well as V2. We just use the size imager to pick our first arrival. Next slide. This is the result for the seismic refraction for all 6 traverses. We'll notice that there is a significant variation in the V1, ranging from about 390 to about 1,430 meter per second, and particularly in traverses 3 and traverses 4 and traverses 5. We also have high velocities, relatively high velocities in the second layer, suggestive of saturated layer because of the range of values of the VP that we are getting. Next. So for the multi-channel analysis of the surface waves, the same data that was utilized for the seismic refraction can actually be analyzed for MESW, and these are some of the dispersion images that we got. From the dispersion images, the dispersion curves were picked, and the resulting S-wave velocity inversion for the models were obtained. The next slide. And this gives us the general S-wave, VS waves for all traverses 1 to 6. If you look at this, you notice that we were able to classify the subsurface into 2. So based on UBC code, for velocities that were less than 200, we classified as low VS and soft soil. For greater than 200, it was stiff soil. And you notice that from here, the cutoff to places where we have at least more than 180 meter per second, it's at about 9.5. And a borehole log that was obtained around that area shows also a variation, a movement from sand to medium dense to dense sand from about that same depth, about 8.5 on the log. Next slide, please. So this is a correlation of results, and this was what I was saying earlier on. So from our results, we noticed that the high positive anomaly on the SP it correlates quite significantly with high values of electrical resistivity, while the negative SP anomaly correlated with low resistivity. And this suggests that—
1 minute.
Thank you. Please, next slide. As a conclusion, the 2D AR revealed vertical vibration, and the subsurface is heterogeneous, yes. However, there is a significant increment in the strength of the soil from about 9. If we are using a foundation within the topsoil, maybe care has to be taken to ensure that the saturation of the shallow layer and the presence of clay units might not contribute to settlement of that foundation. I think that's some, yes. So these are some of my selected references. Yes. So reading the ground before it bears the load is important, and that's why we have to do this.
Thank you very much. I'll give a round of applause, please. Yes. Okay, Professor. Our mic man.
Thank you. Dr. Mrs. Anuku, I'm very proud of you. I taught her, and she was taught by those that I taught. So you can see how she doubles, not only as my academic daughter, but as academic granddaughter. Keep it up, please.
Thank you,
I'm very
Prof.
proud of you.
Thank you, sir.
And you have your academic great grandfather here.
Yes, sir. Thank you
Professor
very much.
Ahaman. Yes. You are welcome, sir. So, having said that, I'm happy you talk about some results correlating with each other. But you could have quantified those correlations. You know, maybe by looking at the depth that you got from method 1 and method 2. Maybe you can just plot one against the other.
Okay.
Using simple Excel software.
Yes, I actually have done that.
So if you do that,
okay,
you can see whether the correlation is weak or strong. It's better than just merely telling us that you have that.
Okay, Prof.
Okay.
Yes,
You also talk about this, that you have a geotechnical borehole there.
Yes,
Yeah,
sir.
I'm happy that you mentioned that. But however, it goes beyond that.
Okay.
You know, you could have recommended again what we call penetrometer test using Dutch comb penetrometer. That will give us a better, it will confirm what you have said. Because we cannot just say, go ahead and start erecting structures. You know, we still need, what you have done is good. It's a guide. In fact, in geotechnics, we call it preliminary investigation. So it can guide us to do more and more.
Okay, sir.
And besides that, we can also, the samples that we are collected in the field, at sites rather, we don't use feed in geotechnics at site. Those samples can be tested. We can determine not only the bearing capacity, but amount of settlement, so that we can then look at the possibility of differential settlement or excessive total settlement of the structures. Well done.
Thank you very much, sir.
Thank you very much, Prof. Are there additional questions?
Okay, thank you, Doc, for the presentation. I just want to see, can we see where your the position of your VES on the 2D?
Yes, just go back.
Go back. VS1. Okay. VS1. Okay. So now 1, 2, 5, 6. Can I see the second VS curve? Okay, this second one is on VS what? This VS.
This VS1 and 2 on traverse 1.
This is VS2.
VS1 and 2 on traverse 1.
Okay, can we now go back to that traverse?
Please, can you go back to the, yes.
Okay. Okay, it's all right. I'm okay. Now the last one. Yes. Your correlation of your
SP and
SP and the MA.
And the resistivity.
Is it resistivity?
Yes.
Yes, SP and resistivity. Yes, the one that shows a very clear the clay. Go to that. About that's second to the last slide, I think.
Yes, please go down. Sorry, technical. Thank you very much.
Continue.
Yes. Here?
No, not this one.
Okay, please go down.
Go on. Yes. So this the second figure there, figure 10. Yes. So you are comparing the SP with your
2D.
With your 2D.
Yes, please.
Now, where you have negative SP.
Yes, sir.
I said it correlates with low resistivity.
Yes.
So what now happens to the other side?
The theory behind that is the saturation level. I'm thinking if you look at this is more like an image. I'm thinking it's just something that we keep refining the model. So I'm thinking that the depth, the resistivity is far lower than at other places. That's one. Or maybe there is we did not take measurements of the elevation. So there might be a possibility that that whole place, everything is seeping towards that whole place. So it's, yes, we showed one borehole. Yes. Okay, groundwater withdrawal probably from far from.
So when we are taking
that place is a clayey area.
That. So if there's a borehole around that place, now if you are taking SP reading and you are pumping water from that borehole, so your SP is going to pick it and it's going to give you negative anomaly.
confirm that, yes.
So that might not be actually because of
It might not be as a result of that particular profile, okay, or the low res. But we saw it was something that was observed across most of the profiles, especially for the high anomaly zone. But it's something we can look out also to further test the hypothesis. All right, thank you, sir.
Thank you very much. Yes, thank you also to our fathers for waiting this long. We really appreciate it. Thank you for setting good examples for us to follow. Thank you, presenters, for making it very eventful, robust.
Thank you so much. We know we have some papers, maybe 2, 3, or 4, we've not been able to take. It's because of time.
It's not proper. What you've just said is not proper.
Okay, so we'll be able to resolve that.
It's all right.
We'll be able to resolve that. We can see that we have about 2 or 3 papers that we couldn't take today. We do sincerely apologize. We'll accommodate as much as we can on Thursday, and that's the decision for now. I would like to thank, please, a round of applause for our chairman and the co-chair for doing so wonderfully well. I would like to also formally introduce in our midst a past president of the Nigeria Mining and Geosciences Society. He joined us, our 21st president. Please, let's welcome in our midst once again Professor M.A.O. Rahman. Thank you, sir, for coming. So tomorrow we'll be having the training workshop. We hope to start that as early as we can. 9 o'clock, we should be on with that program. Then in the evening of tomorrow, we'll be having the awards and dinner night for this year's conference. Thank you, and I wish you a good night rest. See you tomorrow morning. Bye.